All right, so number 8, solve the system by elimination. If the system is inconsistent or has dependent equations, say so. All right, so hopefully we're getting the hang of the elimination process, and let's go ahead and rewrite the two equations from our system out here to the right. Minus 12y equals 9. All right, so again, we want to decide to eliminate either the x or the y from our system, and I think I'll go ahead and eliminate the x here. And so if we have a positive 15x on the bottom, why don't we go ahead and make this x a negative 15, and we're going to do that by multiplying the whole equation by negative 3. All right. And I'm going to write the result under the second equation here. So negative 3 times 5x gives us negative 15x. And then negative 3 times negative 4y gives us a positive 12y. Equals negative 3 times negative 3 gives us a positive 9. And now let's go ahead and add these two equations together. And so we get 15x minus 15x. Well, that goes away. Negative 12y plus 12y, well, that goes away. And so on the left-hand side of our equal sign, we're left with 0 because everything's eliminated. And then our equal sign, and 9 plus 9 is 18. And so here we have a situation where the elimination process has resulted in a false statement, right? Does 0 equal 18? No, it does not. That's a false statement. And so in this situation, we know right away that this solution, or the solution rather to this system, there is none. Because if you were to graph each of these lines on a grid, you would see that they are, in fact, parallel lines, meaning that these two lines will never intersect each other. And remember from the beginning of this review with questions, I think it was number 1 and 2, we talked about that what a solution to a system means is that when you graph those two equations, wherever the two equations intersect, that ordered pair, that x and y, is considered to be the solution to the system. Well, if we have two parallel lines that never intersect, then we never have an xy solution, right? And so therefore we can say that there are no solutions. This is a set of parallel lines and therefore inconsistent. And that's what they were asking us. And for a review of what it means to be inconsistent or have dependent equations, go ahead and take a look at section 4.1 in your textbook, and you will see in the example section there in the first few pages various graphs and what it means to be inconsistent or dependent or to be consistent. All right, so take a look at those and make sure that you're familiar with them before the test. All right, let's go ahead and move on and take a look at question number 9 here in our next video.